Today we're going to learn bubble sort. This is the simplest way to sort an array in O of n squared time. So in this algorithm, we're going to repeatedly compare adjacent two elements of the array and swap them until the entire array is in increasing order. So in the first pass, we're going to compare index elements 0 and 1, which are 5 and 2. And since 5 is greater than 2, we're going to swap those. So the array now has 2 at index element 0 and 5 at index element 1.
Why only adjacent swaps?
Yeah, that's a great question. So bubble sort works by fixing local inversions. And as you swap elements that are neighbors, the larger elements move toward the right. So moving forward, now we're going to compare index elements 1 and 2, which are 5 and 9. And since they're already in order, no change. So now here's the rest of the first pass through the array. We compare 9 and 1. We swap so that 1 is before 9. Then we compare 9 and 5. And we swap so that we now have 5, then 9. And then we compare the last two elements, 9 and 6. Again, swap so that we have 6 before 9. Now the first pass through the array is complete, and the final array after the first pass is 2, 5, 1, 5, 6, 9.
Do we need to touch the last element again?
That's a very good question. So notice now that 9 is in its final place in a sorted increasing order array. And that is because after each pass through the array, your largest element is going to be at the last position that it could take in that array. And after that pass, we're going to shorten the range that we go through the array by 1. So the first pass, you go through the entire array, and by the end of it, your largest element will be the last element. And then in your next pass, you will go through the entire array except for the last element. And then the second to last element in the array will be in its correct final place. So let's discuss the time complexity of this algorithm. Since in an array of n elements, you are able to compare neighbors n minus 1 times, and each pass through the array, you exclude the last element of the past, meaning in the first pass, when it's complete, in the next pass, you're going to exclude the last element. It's already been sorted into its final position. That means that you will have to do enough passes, n minus 1 in the first pass, n minus 2 comparisons in the second pass, summation until you get to the last one where you're just comparing the last two elements. The time complexity comes out to be an O of n squared operation. So because of the time complexity being O of n squared, it's not going to scale well for large arrays or large data sets. This is best for small data sets and when you're learning about sorting.